Hello everyone. In this session, we will learn how to write callouts in the Onfinity system. The purpose of this training is to understand the usage of callouts and where we can implement them within the Onfinity system. Let's understand the agenda for this session. We will start by understanding the callout overview, define what callouts are, and then explore how callouts function within the Onfinity system. We will now cover how callouts are written, focusing on how to initialize callouts using the MPC, that is module prefix code. We will also understand how to define a callout class. Following this, we will explore the callout engine and then learn how to define functions using function prototyping within the callouts. It's important to note that you can define multiple functions within a single callout class. Also, you have the flexibility to define multiple classes to manage different functionalities for your callouts. Next, we will understand the callout parameters, focusing on the parameters that are used when callout functions are invoked, and how namespace assignment is performed for the callouts. We will then understand callout binding, focusing on how to link callouts to specific columns. Following that, we will explore the common methods for callouts available within the Onfinity system, which are provided by the Onfinity framework. Finally, we will understand messages for culture implementation, which allows us to provide customized messages to the user, including error messages and informational messages defined based on the callout. To bind a callout to a specific column, we need to access the menu configuration. This involves navigating to the menu section from the home screen. Once there, we need to access the database schema, as the goal is to link the callout with a particular column in the database. Then, we proceed to the column tab and locate the specific column to which we want to link the callout. It is possible to have a single callout associated with a specific column. It is also possible to have multiple callouts linked to a single column. We will show how and where callouts are linked in the next screen for your overview. As shown in the database schema screen, we are currently viewing a specific table and one of its columns. At the bottom of the screen, there is a checkbox labeled Callout. To enable the callout for this column, you need to mark this checkbox as true. Next to the callout checkbox, you will find an option to define the callout code. In this example, VA001 represents our module prefix. Following that, VA001 underscore callout ORD indicates the class name for the callout. And finally, .setBP location represents the method name that can be called from this particular column. For this example, the basic functionality we aim to achieve with this callout is to automatically set the location for a customer whenever a user selects that specific customer. This is one of the examples we will cover in this callout section. We will write the set BP location callout in this example, and then understand additional aspects of callout writing. Specifically, we will learn how to write these callouts using the partner kit for a specific module. Let's understand how the partner kit is set up for callouts. We will write the callouts within this partner kit. The partner kit setup was covered in a previous session. If you missed that session, you can review the partner kit setup materials. In this solution file, there are 3 projects: Vienna Advantage, Vienna Advantage's SVC, and Vienna Advantage Web. The callouts will be located under the areas directory, within the scripts directory, and then in the module folder. A sample callouts.js class is already available there. We will be writing the callouts in this module folder. Before we proceed, there are some additional settings required when working with JavaScript files, whether they are callouts, pages, or third-party libraries. As we covered in the Partner Kit session, Vienna Advantage includes this application. You need to define the assembly name and the default namespace. In the build events, you will find a post-build event that should already be defined in your Partner Kit. For the pre-build event, you will have to write npm run build. If it is not already there, you need to define it in the pre-build section. The next step involves area registration, which we already defined in the Partner Kit session. Then, in the Webpack config, we have the entry points that we need to adjust. The entry points are specified for the areas and scripts. If we examine this, it is located in areas VA001, scripts, then the SRC folder, and finally VA001.js. This JS file will include all the JavaScript files that we write, including callouts or pages. We'll review this again after we add the callout file. In the Webpack config, the left-hand side of this entry point is VA001. Therefore, the path of this VA001.all file should match the path defined in the web config. When Webpack runs, it will bundle and minify the JavaScript files that we have added. It will then create these minified files with the specified name. This name should match what we defined in the area registration file. The final name will be va001.all. Then this name from this section .mine and version.js. In the area registration, you will see all.mine and then version.js. If this name is incorrect or does not match, your JavaScript file will not be loaded correctly. In the package.json file, we have the name of our module. You should change the module name here to match your module name. This ensures that when the JavaScript files are loaded into the browser, you can find those files under the correct directory in the console for debugging purposes. I will now close all these files. We have completed the Webpack configuration. Area registration is also finished. Now, in the model folder, we need to add a new callout for our functionality. I will click on Add a JavaScript file and name it va001_callout_ord. This creates my class with the name callout_ord.js. I will then copy the entire content of the existing callout.js file and paste it into my new class. I will keep the original callout.js file as is for future reference. This allows me to easily check the original structure and content of the callout class if I need to make changes or understand how things should be implemented. Looking at this callout.js file, we can see the MPC, which represents the module prefix code. We need to replace this MPC with the prefix of our module, which is VA001. We will use VA001 as our module prefix for this example. I will replace all occurrences of MPC in the current document, and there are 9 occurrences that were replaced. Here, we are initializing the namespace for this callout for our module. If it finds VA001 in the DOM, specifically in the window object, it will assign this callout to that existing object. Otherwise, it will create a new module namespace called VA001 in the window DOM. Then, we have a self-invoking wrapper function here. This is a standard syntax for all our callouts, and we do not need to modify it. In this section, we have the module prefix. The module prefix has already been changed to Vienna Advantage, as we did initially. Additionally, there are some standard functions provided by the alternative framework for logging errors or informational messages, and certain utility functions that will be provided by the framework. Now, we have the class name. I will rename our class name to match the class name we created for our callout, which is va001_callout_ord. I will replace all occurrences of the original class name in the current document. Wherever we find the name test class, it will be replaced with our new class name. Here, we are initializing our callout with the callout engine, which is provided by the framework. It is important that our callout calls the base class, meaning that our callout should inherit from the callout engine class. There are certain functions provided by the callout engine that we can use within this callout class. In addition to those, we can also create our own functions for our specific callouts. As an example, we can see the function callout class name prototype.set. This is the function name that we will assign to a particular column when we link the callout to that column. This function has parameters, and these parameters will be consistent across all callout functions. The first parameter is context. The second is the window number. Each window has a unique dynamically generated window number. The third parameter is the object of the M tab. For the tab that contains the column where we have linked this callout, you will have access to all the properties of that tab through the M tab object. The column where the callout is linked is also further linked with a specific field. That field will provide us with all the properties of that specific field. The value parameter will give you the current value of the column where we have linked the callout, as well as the previous value of that column. If we are updating a value in the column, the value parameter will provide the previous value, because it represents the old value in that column. We also have an isCallout active check here. If the callout or any other callout is currently running or executing, this check will prevent the current callout from executing. This ensures that we let the existing callout finish before running a new one. Once the existing callout is finished, then we can execute this callout. We also have this callout active flag. We need to set this flag to indicate that the callout is active, which helps prevent conflicts with other callouts. Therefore, we will set this callout as active. The core logic for the callout will be implemented in this section. Here, we can retrieve values from the control itself on the client side and set values in other columns on the tab. Alternatively, we can implement functionality to retrieve data from the server side and set values in other columns. After the logic is executed, we are setting the callout active flag to false. In this section, we also need to set all these parameters to null, and field value and old value equal to null. Then, we are returning from the function. This is one example of a function that can be written here, but you can define multiple functions within a single callout class. Based on your specific requirements, you can decide whether to include multiple callouts in a single class, or define each callout class separately and write your functions within those classes. Then, we need to assign the class to the model. To maintain compatibility with our existing namespace functionality, where we were using these model namespaces, we can ignore it in our case and keep it simple by defining it as va001 dot, followed by our class name. We have now defined one callout class with a specific name. This callout class must be defined in the src folder within the JS file. To do this, we need to import it from the model directory because that is our path. We then specify the callout class name followed by .js. As you can see, we have the model folder. Inside this model folder, we have our class. We have already defined the path name here. If you have other JavaScript classes, you need to add them to this file as well. All the classes that you want to include in your package need to be defined here. Once we have completed this, we can build the code and check if we can locate our class in the console while debugging. As you can see, the Webpack configuration is complete, and it is now building the Webpack. I will now run the build process. Now, I will log in using my tenant credentials. Here, we will check whether our JavaScript class is loading into the DOM. As you can see, our JavaScript class, va001 underscore callout ord.js, is available in this section. The goal with this callout is that when we navigate to our demo sales order screen, which contains two tabs, order and order line, and toggle to the order line tab, and change a value, let's say to 8. When I click or press tab, the quantity ordered value remains at 9 and does not change. The intention is that when I change the value in the quantity entered field, it should automatically update the corresponding value in the quantity ordered field. Users can manually change this value later if needed based on their requirements. However, according to this specific scenario, I want to automatically set the value of the quantity entered field into the quantity ordered field. To achieve this, we need to implement the logic within our callout. Now I will log out. First, I need to link the callout to the quantity entered field. I will go to the database schema and search for my table, VA001, on the order line table. Within this table, we have the quantity entered column. We will link the callout to this column so that when the user changes any value in this column, the callout will execute. Now, I will bind the callout here. The callout code should be your class name, in this case, VA001 underscore callout ORD. Then add a dot, followed by the name of the function. Now I will change my function name to setQuantityPrice. I will copy this function name and paste it here, then save the record. This is the specific callout that I want to execute when I change any value in the quantity entered field. So I'll stop the current code execution. And in the code, I will select the column in which I want to set the value. If I know the name of the column, in this case it is quantity ordered, and we are going to set the value of this column. The value parameter represents the column value from where the callout is being triggered. Since we have linked the callout to the quantity entered field, this value will be the value of the quantity entered field. We are setting this value into the quantity order field. Let's build the code, ensure it succeeds, and then run the application. We will log in with our tenant credentials and navigate to our screen, the demo sales order. From here, we will go to this specific record, then to the order line, and toggle it. Now, when I change this value, my callout is triggered, and it is retrieving the value I am entering. If I enter 8, it is updating the value in the quantity ordered column accordingly. Right now, we have entered a value in the quantity entered field. I want to set the value in the line net amount and line total fields. The calculation should be the quantity entered multiplied by the price entered. Whenever I change the quantity, this multiplication result should be set in the line net amount and line total fields. Let's implement this now. Here, we will use mtab.setToValue and specify the name of the column we want to update, which in our case is line total. We want to set the value in line total as value multiplied by mtab.getValue, where we will pass the name of the column from which to retrieve the value. In our case, we want to retrieve the price from the price entered column. So this is how we will set the value in the line total based on the quantity entered multiplied by the price entered. It's important to know the names of the columns from where you want to retrieve the values. Now, when we run this code and log in with tenant credentials, we can navigate to our screen, the demo sales order. On the order line, I will toggle this. When I change the quantity, let's say to 20, the line total is updated to 8,000, as you can see. Whatever value we are changing here, it will update in the quantity ordered. We are also setting the line total as the multiplication result. For example, 800. If we change the value in the price entered field, nothing happens in the line total column. This indicates that it needs to work vice versa as well. When we change the value in the price entered column, we also need to update the value in the line total field. Let's explore how we can achieve this. To achieve this, I will go back to my callout class and stop the code execution first. I will copy this existing callout function and paste it below. I will rename the new callout function to setPriceTotal. The other parameters will remain the same. These checks will remain the same. I do not want to set the quantity ordered on this price change. I only want to update the line total. In this value column, I will now get the value of the price because this callout function will be linked to the price entered column. Therefore, here it will be price entered and we will multiply this with the quantity entered column. That is what it will do. It will set the line total as the price entered multiplied by the quantity entered. Similarly, we are setting these values in the line total as quantity entered multiplied by the price entered. This will now work in both ways. Whether the user changes something in the quantity entered, or if the user changes something in the price entered column. I could achieve this with the same function, but I want to illustrate how we can write multiple functions within the same callout class. I will log in now and link this function to the price entered column. First, I will log in with my system administrator credentials, using the system administrator role with the system user to bind the callout to the column. Now, I will go to the database schema to link the callout. In the database schema, I will find the order line table. In the search section, I will search using my prefix VA001. Here, we have the order line table. In the column section, I will go to the price entered column. I will set the callout checkbox to true, and in the callout code, I will bind the callout using the module prefix namespace, the class name, and the function name, setPriceTotal. Now, I will save it and perform a cache reset. I will close this and log out. Then, I will log in with my tenant credentials and navigate to the demo sales order screen, specifically to the order line tab. Now, I will toggle this. If we change the quantity here, the line total is calculated correctly. If I change the price, you can see that the total is also updating when we change the price entered. For example, if I enter 4,500, the value is calculated accordingly. This demonstrates what we have achieved with the callout. Based on the fields on the UI, I can retrieve the values from one field and set them into another field. There are two different types of callouts. One type involves observing, where we select the value directly from the current table, utilizing the current fields. These are not just straight fields on the current table. Another type of callout involves using lookups, calculations, or similar methods. These are not straightforward fields found directly on the current table. Another column type involves retrieving data from the server side. For instance, consider a product. Upon selecting this product, I want to set the UOM for it. Furthermore, I want to fetch the price from the product window. Currently, if I zoom into the product screen, we find the UOM of the product there. Additionally, there is a price tab where the price for that product is specified. We will retrieve the data from the product and product price screens. The product master has the product we selected onto the order line. If I toggle this, you can see this product has the UOM as each. The product price from the price tab indicates a sales price and a purchase price of $550 as a list price. As soon as the user selects the product, we will retrieve the UOM from the tab. We will also dynamically retrieve the price from the price tab of that product. To accomplish this, we will use AJAX calls, leveraging the concept of MVC. We will define the controllers on the server side. We will then call the AJAX to retrieve the data from the server side and set the values in the designated fields. I will copy again. Then I will write another function for the product, named getProductDetails. I will bind this callout to the product field. I will fetch the values from the database and set them on the UOM and the price. Therefore, I will remove this, as it is not required. There are two options. You can use your own AJAX calls by writing a syntax, or use an inbuilt function within the framework to retrieve the values for the callouts. I will declare a variable result of prod_details equal to vis.dataContext.getJSON record. In this, we must first define the module prefix, then the controller name, and finally, the name of the function. Let's say getProductDetails. The second parameter is the parameter that is required. For example, if we link this controller or this callout on the product column, we want to fetch the respective UOM and the price of that particular product. We will pass that product as a parameter to the server. We will then retrieve the details of the product from the server side and set those values in this field. I will receive the result, specifically the product details, in this variable. I will then check if the value is not null. Then I want to set the values using mtab.setValue in my UOM field, which is c_UOM_ID, which I will be returning from the server side. In the same way, I will copy this and use va001_price entered. I will return these two values, UOM and the price, from the server side. Now, we need to write the controller for this. In the controller section, we will click Add and then Controller. We will add the empty MVC controller. We have named this product controller, so we will add this empty controller here. I will remove this over here for a namespace, though you can leave it as is. I will write a function that will return a JSON result. Our function name is getProductDetails, and it will accept one parameter, fields. When you are calling the controller with the inbuilt Vienna Advantage Framework function, getJSONRecord, the parameter name is always fields, allowing you to manipulate it according to your needs. Right now, it will be giving the product ID, though you can have comma-separated multiple parameters that you can define. You can also pass these from this JavaScript code to your controller. However, in our current case, there is only one value, so I am writing it here like this. First of all, I want to get the context. Therefore, you have to write the CTX. I will check which namespace this particular context exists in, using vadvantage.utility. _CTX equals session. I will get the context from the session. Then CTX as CTX. And this should return this JSON result. I will be returning this as a JSON and JSON converting using newtonsoft.json.serializeObject. Here, I will be passing the second parameter as JSONRequestBehavior.allowGet, in case we are calling the get method. Now, we will write code to retrieve the values from the product, such as the UOM and the price. In the Solution Explorer, within the VA001 area, we will add another folder named Models. Inside Models, we will add a model file, a model class. Let's say, order model. In this model, we will write our logic to fetch product details. Again, I will keep my namespace as va001.models. I will define here public dictionary string and object as a return type getProductDetails, which will be accepting the first parameter as a context and the second parameter as a product ID, in our case for now, like this. It is expecting the return type as a dictionary, so I will return product details. I will return this value, so this is our model that we have defined over here. We will pass the values, so let's complete our controller first. This is the order model that we have created, and it is in va001.models. We will create an object of this. Here, we will be returning the values from this order model, dot, and get product details, which is our function in the model. It is expecting two parameters. The first thing is context that we have defined over here, and the second parameter is this variable that we are passing from the JavaScript code where our callout is linked. Now we are getting the product details from here. If I navigate to this function, we have passed the product ID and the context. We now want to fetch the UOM and the price of that product. I will create an object of an M class for the product. Maybe later on we will want to fetch other values from the product like description, value, SKU, UPC of that product. But right now, I just want to fetch the UOM only. Product equals to new M product. The first parameter of this is context. Then the primary key of this table, this one. I will type cast this as we are passing this value as a string, and the third parameter as null, as I am not passing the transaction. Now in the dictionary, I will add the first value for the UOM, the UOM ID, which I will be fetching for this, like this one. In our callout code, we are writing this, stating that it will be setting the value of this UOM field, which is being fetched from this UOM ID. That's why I have added it into this dictionary as this UOM ID. We are fetching the value for the product that we have passed from this jQuery. Another thing we want to do is fetch the price of that product. We will write a query. We can also do that from M class, but this is another way I am demonstrating to retrieve the values from a query. I will use database.execute scalar. Here, I will write select price list from m_product price. That is our table where the prices are stored for the product from m_product price, where m_product_ID equals this product ID that we have passed in the parameter, as we want to fetch the value for this product. Here, I will add this into the dictionary price, like this. We are fetching the value for this price and updating this value in this dictionary so that we will be passing this back to the control. Let's observe this code in action. I will build this and set a breakpoint here so we can observe how this code is being executed. Currently, we haven't linked this callout to the column, which we will do now. I will run the code. Now, I will log in with the system tenant. Then, we will link this callout to the product field, so that when the user selects the product's UOM is fetched from the server side and set in the UOM field. Also, the price will be fetched from the product's price tab. Let us just log in with the system administrator role and link the callout to the product. We will navigate to the database schema and search for a table with the module prefix VA001. On the order line, we will go to the column. We need to link the callout to the product column, so we will mark this callout as true. The callout code here is this path .get product details and save it. Now we will do the cache reset and click OK. Then we will log out and log in with the tenant. From here, we will navigate to Demo Sales Order. From this record, we will navigate to the order line toggle. We will then click on a new record. On the product, we will select, let's say, SFP connectors. As soon as we press Enter or press Tab, you can observe that the breakpoint is there. We will debug it further. Now, we will go to our model. This is the product ID of the record. As, when we pass the context, we created an object of the product. We will fetch the UOM ID of that product, and then the price for that product. Furthermore, we are returning this dictionary back to the UI. As you can see now, the price and the UOM are fetched. If we debug it further onto our JS file, I will put on a breakpoint again. Then I will change it to, let's say, netcom. As you can see, the callout is marked as active. and we have called our controller to fetch the details for this product. This is the product ID. Once we run it, and in the AJAX here, we receive the response that the UOM ID is 100 and the price is 350. If the values are present, we are setting these values into the column. We will close it and disable our breakpoints. Then, we will observe the price and the UOM. Now, if I select SFP connectors again, it displays the UOM and price. If we change to another product, let's say this one, it shows the UOM roles and the price as 450. If we zoom into this product, we can verify whether it is selecting the correct value from the product master. On this product master screen, we have the product that we selected onto the order line. This product has the UOM as roles. If we navigate to the price tab, we can see that the list price is 450, which is being selected here. Since we have not set other values in the tax amount line total and all of that, if we make changes where we have adjusted the settings to fetch this line total, it will work accordingly. We have now observed two distinct types of callouts. The first type involves retrieving values directly from the UI, performing some calculations, and displaying the result in another field. The second type involves retrieving data from the server side. For a product, we called our controllers, fetch data from different tables, retrieve the values, and set them in these fields. That is how callouts function. There is additional functionality that we can achieve with callouts. For example, in this table, if I have 10 to 15 fields and I don't want the user to select a particular field or any particular data in that field, or if I want to do some calculation and don't want the user to enter a quantity more than, let's say, 6 or 10, then I want to restrict the user. Earlier, we have observed the M-class session and observed how we can restrict on the save and display messages to the user. However, that restriction occurs on save, after the user has selected 10 to 15 values and entered all those values. Only then do they discover that the value was restricted and they are not allowed to save it. To avoid this, we can apply logic as soon as the user enters a particular column value and display the message at the time of entry. This can also be achieved with callouts. Let's observe how we can accomplish this, so I will show you in the callout. We have bound this callout to the quantity price or to the quantity field. Here, I will write, if the value is greater than 100, vis.adialog.error. I will write a fixed message here in plain text. It is recommended to use the message screen, and we will get to know about that later on. How to retrieve messages from the message screen to implement the culture. For now, let's say you cannot add a quantity greater than 100, and then I will just return from here and build it, then run it. Here, we will log in with tenant credentials. We have set the callout on the quantity change, and we are checking if the value or the quantity field is greater than 100. Then, we are displaying an error message to the user and are not waiting until the record is saved, as we are checking the value as soon as the user enters a value in the quantity field. Once we are logged in into the system, we will navigate to our screen, which is the demo sales order. We are now at the second record. We will navigate to the order line and toggle it. In the quantity field, if I change this value to 60, it does not display any message. However, if I change it to 120, as you can see, we have the message that we defined there. These messages should be retrieved from the message screen. We will get to know more about these messages in the message and the other log and transaction session. Currently, we have retrieved this from the message. As you can see, we are receiving this error message. The icon in front of this message is a red cross, which represents an error. There are other types of messages as well. If we return to our code and change adialog.error to adialog.info, we have info warning and these types of messages. I will run it again and log in with my tenant credentials. Then I will navigate to the screen that is Demo Sales Order. Here, in the screen, we will navigate to the second tab and toggle this quantity. If I change this, you can see the icon has been changed to the info icon. You will see this info message here. This is how you can display different messages according to your requirements. These are the messages that are displayed to the user on the screen. Additionally, there are other kinds of messages that are logged into the backend. If we navigate to the settings section here, in the preference, we have this preference error. By default, this error is only true. If we change it, we can observe these info messages here. We have this log setting. The trace level is currently off. If we intend to display a specific type of messages onto this, we can enable it from these trace level settings. For the time being, I will mark it as all and also trace the file. Then, I will save the changes. These settings are saved for me, and for my user, these preference settings are user-specific. I will now write a warning in the callout class here. I will put this.log.warning, and here I will put this is just a warning message, and save it. I will run this. This message will be written into the preference section, into the log, which is not displayed to the user. However, the other message, you cannot add more quantity greater than 100, will be displayed to the user if the user enters a value in excess of 100. I will again log in with my tenant credentials and go back to my Demo Sales Order screen. In the Demo Sales Order screen, within the second record for the order line, I will toggle this and change the quantity so that my callout gets executed when I press Tab. Currently, the message is not there because we haven't entered a value in excess of 100. In the Preference section, if I go to my preference error and mark this, you can see the message, "This is just a warning message, was executed at this particular time, 15:25. This demonstrates how you can also write log messages in cases where you do not want to display messages to the user, or if there is logging functionality you want to implement to check if something went wrong with the code, you can use this log feature on the client side. That concludes the information regarding the callout sections. We have observed how callouts are written into the partner kit for our module. There are two distinct types of callouts. One, where we are retrieving values from the client side itself, from the UI, and another where we are retrieving values from the server side by calling the controllers and fetching the data from the database or some other table. We then set those values after performing calculations onto the UI. That concludes this session. Thank you for attending.